Hello everybody, welcome to our new live stream for this Friday, which has the topic to introduce you EcoInvent 3.7, the new version in OpenSCA. I'm Andreas Siroth. I'm sitting here with Salva, that you don't see, from Green Delta. Hello everybody. I'm sorry. Welcome to our new live stream for that was unplanned. This Friday, which has sorry for this. So you see, this is my first time I'm doing this, so therefore if I'm making a fool of myself, please bear with me to some extent. I hope that you enjoy this and that you can take out of it what you need. I'm going to cover these points. First, introduce shortly OpenSCA for those who don't really are not too familiar with it, but I assume most of you know OpenSCA, and therefore we are not going to spend too much time on this. And very shortly, Green Delta, the company I founded and work for. And then focus will be EcoInvent in OpenSCA. First, EcoInvent 3.7, what is new, what you can expect, how is it organized. We will then show live EcoInvent in OpenSCA, refer to some practicalities, and hope we have also some discussion. I just shut down my the channel in my notebook, so let's see how we do this, but we'll find a way. Good. OpenSCA it's very bold here, but is a free and open source software for lifecycle and sustainability assessment that we developed since 2006, available from OpenSCA.org. We think it's now really the most widely used LCA software today, and our aim is to, and has always been, to develop software that is more flexible and more powerful also than commercial LCA software that of course exists also, and at the same time that is easy to use and does not have a high entry barrier, so that you need to be a super expert or take 2 courses to understand it, but that is quite, it's an expert software, but it's quite easy to use. And also to model close to reality and also in line with LCA methodology. And just some examples for this flexibility and ease of use that we think have to quite some extent implemented now. We have processes that are distinguished from flows, and processes can have main products on both input or output side, just as you have it typically in real life or in reality. Input products are typically found for waste treatment processes, so an incineration plant takes up waste for treatment as input. We distinguish processes from products. As I've said, we connect processes by waste flows or by product flows and not by elementary flows, because this is not following ISO. And we show, or we have product systems that show the model life cycle and that can be edited. And we don't have a hardwired supply chain in the database, but you as a user and as an LCA modeler, you can create a life cycle, of course, based on the information in the database, also based on information that you add yourself, and then make your life cycle. We have many different databases for OpenSCA, mainly or namely LCA databases, input-output databases, for environmental LCA, which is the main focus, of course, but now recently also some databases for social LCA, and some of the environmental LCA databases contain also costs, so therefore you have also a lifecycle costing database. Gabi, as you may have heard, Gabi databases are not provided by us anymore because it's a decision of Sphera, the owner of the Gabi database, but they can also work in OpenSCA, and you can get all these databases from Nexus OpenSCA.org. Green Delta, I'm not sure if anybody is interested to hear something about us, but we are a sustainability consultancy and software development and database development company in Berlin, in Germany, founded now more than 15 years ago by me. One important part is, or a quite relevant part of our work, is to develop and maintain OpenSCA as open source software. Of course, if you're interested, you find more information out. And now comes EcoInvent 3.7. There was an EcoInvent webinar 1 week ago, so initially it collided with our planned webinar, so therefore we postponed this one. EcoInvent was released in this 3.7 version in September 2020. You know that EcoInvent, the EcoInvent database is released by the EcoInvent Center, and we made this available really since beginning of October. And you see here also if you want official information about EcoInvent 3.7 from EcoInvent in this link here, there. And it contains new data sets, about 900, quite a bit more updated data sets, and new products for these sectors: metals, fertilizers, energy, wood, paper, pulp, recycling, cans, paperboard for recycling, and construction, which is only glass wool. Altogether, you have 19,000 data sets per system model. And when you look at these figures, you maybe realize that it's not a revolutionary, complete new database, but it's more an evolutionary improvement of the database. So it's quite broadly used worldwide, really, and therefore I think it also makes sense to not drastically change everything, but to improve it gradually and evolutionary. In EcoInvent, you maybe know that we have 3 system models, meaning databases that use different allocation, end-of-life modeling, and process linking. And these are cut off by classification, which is the default of the EcoInvent database is in line with the previous version of EcoInvent, EcoInvent 2.0. It is an attributional lifecycle inventory modeling approach, and for recyclates, so like recycled paper fibers or recycled glass collets or so, the impacts of the first life cycle are ignored. Allocation at point of substitution, it's more complicated, and I don't want to go too much into detail. You find information on the EcoInvent website about this. Means basically that for recyclates, so for paper fibers, for example, the first life cycle is considered at the point where these paper fibers are used to replace virgin fibers in the next life cycle, and then also the impacts are to some extent considered. And then you have a consequential system model that is following the consequential LCA approach. And maybe side note, there will be a workshop on Monday where I will talk about consequential LCA. The entire day is about consequential LCA, organized by Helsinki University. Maybe you find information about this somewhere, but this is not linked to EcoInvent. Yes. Each of these, so what is provided, second page, each of these system models is provided by EcoInvent as unit process, and it's called LCI, so fully aggregated system process database. On the EcoInvent website, you find also an unlinked raw version of the database, and also EcoInvent provides a specific impact assessment method package for the EcoInvent database, and the aggregated system processes also as impact assessment results are available. Okay. Then now the main part, and now give me a second because I'm starting again my the browser, and just muted, that should work. EcoInvent in OpenLCA. So like this, sorry. We are resellers of EcoInvent, and therefore we have a long collaboration with EcoInvent, and if you order from us the EcoInvent database, We provide you the full EcoInvent license, of course, with access to the EcoInvent website, plus the data packs that we prepared for OpenSCA. And therefore, we provide this cutoff RPOS consequential system model as inventory aggregated full system process and as unit process, plus the impact assessment method, and plus also an OpenSCA impact assessment method that is applicable for EcoInvent, but also for other databases that we provide. So all processes, all system model versions in summary, and we get really the same, of course, results in OpenSCA when you calculate the unit process-based life cycles as is released as the fully aggregated system models by EcoInvent. Also for the inventory system processes, but also for the impact assessments. And the last bullet point is, in addition, we have made what we call regionalized version. That is a slight change or improvement, you could say, of the EcoInvent database, where we have added more locations to flows which are addressed in region-specific impact assessment methods that are for some reason don't have this region information in the original EcoInvent database. So therefore you get that's a slight deviation or extension, you could say, of the EcoInvent database. In this Nexus page, which I refer to, this looks like this. So it's really, if you're selected there and have also access to EcoInvent there, you get all this. It's the download page. You get all this for download. You see, so it's 3.7 RPOS LCI, RPOS unit, and so forth. So that's really, and the method. So this is really what you see, and then you can click here and download this, and that is what we provide. Now, maybe it's also interesting what we don't provide or what we change compared to the official version of EcoInvent. Three things. First, what I call, it's a bit not so nice, I call, and someone else has also talked about double negative things. I think, so let's stop this discussion, but this double negative waste modeling in EcoInvent is not supported by us, or we changed this, and I will show you, and hopefully you agree that this is also, or maybe even more convenient as we do this. We model waste flows as waste flow in reality, so a process that produces waste and gives it to a waste treatment process has this waste flow as output in OpenSCA, and it's an input in the waste treatment process. That's really very easy to follow this, and quite intuitive also to model like this, and it's not done like this in the EcoInvent database. We don't support exchange properties and parameters. We also don't support, unfortunately, because the version that EcoInvent releases contains parameters, but they refer to a pre-distributed version, and they allocated, so where the data sets are already allocated in this set, the parameters are not correct anymore, and this is what we receive, and therefore we can't unfortunately reproduce these parameters, and therefore can't also share or shouldn't share these with users. And it's a bit not, hopefully this changes. We had some discussions or brought this up already sometimes, but this is the situation. So therefore the data sets that we distribute don't contain parameters, even though the EcoSpol 2 format versions of EcoInvent contain parameters that EcoInvent distributes or shares. The double negative, one example. So this is just one waste treatment process in EcoInvent. This is a screenshot from the EcoInvent EcoQuery website that you may also know. It's treatment of waste aluminium in a sanitary landfill in Switzerland. It's a process. And it has as reference product on the output side -1 kilogram waste aluminium. And that is because in the EcoInvent logic, every process must have the product on the output side. Of course, the landfill takes up waste as input and not as output. And on the other side, and in addition, basically input and output is only a matter of the sign of the amount. So therefore, if we say minus the amount, this changes the input and output side from here input to output. Therefore, the waste aluminium is output -1, which means it's really input 1 kilogram. And in OpenHCA, this looks like this. So the same, exactly the same process. In the APOS model, you see that it has waste aluminium as input 1 kilo and some emissions and so forth. And this is, I think this is an improvement, because in the EcoInvent model, this has the consequence that a process that has waste aluminium as output must not have this as output, because otherwise it can't be delivered to the landfill that is has also aluminium as output, but you must have it as minus input, and therefore this double negative name. Yeah, and this is quite, if you forget to set it minus, then you change the direction, and so therefore this is quite a source of error, and therefore it's good, I think, that we don't that we change this. Second, exchange properties. There's also a screenshot from EcoInvent, the EcoInvent website. So the original, if you want, data sets for the same process, copper emissions to air. EcoInvent provides for every exchange, so flow that is input or output of a process, a set of properties that you see here, so carbon content and so on, dry mass, and you see that the water content of copper is 0 and so on. So it's somehow surprising. So this is always the same structure for every exchange, and quite often it's not adding much, and therefore we don't provide this, but it's also maybe, so it's at some point it has a benefit, and therefore we think about this, but not at present. The version that you receive does not contain this information. Yes. If there are now no further questions, then I can show you OpenHCA how it is. So this is you see now OpenHCA. Yeah, it's funny because I have always a bit of delay, but you see now OpenHCA. The chat is very quiet, so maybe if you can say hi, that would be useful. Otherwise, I can just explain. I hope you see it. We tested a bit, and it should be not too small. I hope that's true. So here, this highlighted thing is the EcoMan database that I'm going to show, the APOS unit system model. And what do we have here? We have here some, this is the same structure for every OpenHCA database. We have some units, actors, sources, and so on. Then we have here, I imported already impact assessment methods. Then we have here flows, and the most interesting thing is probably processes. EcoInvent provides the processes in an ISIC sector structure that is quite convenient, and we also follow this. So therefore you have here the ISIC sectors, and I didn't plan what I know. Market process I don't want to open, but rather something else. This is one process where we see palm date production. You see here the general information, start and end date, and some meta information. And the most interesting part probably is for every process the input and output sheet. We have here, well, you see these are products and the amounts, of course, and these are outputs. You see here again that we have a process that has wastewater, and that is this means it's a waste, so therefore it's really just an output of some wastewater in cubic meters. What we have also is that we have a provider here, so this is the process that delivers chloro-difluoromethan to this palm date production process. And we have here data quality entry that is that's also provided by the EcoInvent database, and that is also provided by us. Then there you see then this pedigree schema for data quality assessment, where you see this is the reliability to technological correlation, sorry, and in score from 1 to 5, and 1 means best and 5 means worst. And And you see here also an uncertainty that is developed, or that is calculated based on the what you click here. Yes, that is maybe the most interesting part. Yes, thank you for the question. Show demonstration how to import. I will. That is very fast, and I can do this afterwards. I am now going to show the most interesting part. I think that is this product system. And has anybody an idea what kind of product system or what kind of life cycle I should model here from EcoInvent 3.7? So do you have some ideas? Otherwise, I just select something. No. So then I just select something on myself. Or I wait until I count until 5, but then meanwhile I select something. Yeah. So I didn't plan this really, but yeah. So then I can select something. What I can show you here, that was a global process, so therefore that doesn't show anything for the region. But when it's not a global or rest of world process, then we show in OpenSCA here the specific region where this process is occurring. This is Europe, but you can really, this is OpenStreetMap, and can also define very specific locations for a process. So it's quite interesting when you think of regionalized LCA models. That is, yeah, that becomes quite convenient. Oh, Gerhard withdraw his message. Okay, fine. Then I just create a product system. So this is an automatic, basically automatically create, or will be an automatically created life cycle. I click on create product system, then I leave this here auto link processes, and that means that the links that are provided by the database are followed and yeah, used to build the product system, which takes a while, of course, but it's not too long. So I thought it's fine to do this here really live. So this is now the linked lifecycle. When we check here, then it's a bit. Sometimes you have already the very first process here has many different impact inputs, so therefore that is not too easy to have a look at. We see this also when we look at the process. Yeah, it's quite a large process already, but fine. We can also see here in the statistics how many processes are really part of this, and that's in EcoInvent always so that normally almost all the processes that are part of the database are linked in the product system, but of course you get different results because the share is different with which each process contributes. You see we have here 15,400 processes, and it's always also quite similar, 450,000 links between the processes. And some, this may be also interesting to look at, this is the processes that have the most input products, so linked inputs, and you see that some treatment of waste graphical paper has 3,600 input products, and on the other side some processes are their products are most often used. That's also shown here. Not too surprising, maybe surprising that it's Australia, but market for electricity is 1,400 times used. It doesn't mean that maybe the amount is high, but just the there are 1,400 different occasions where this process is used. Okay, then this is the life cycle basically. When we can now also calculate this. I select an impact assessment method. Any preference for an impact assessment method? If not, then I just select one, and I check here assess data quality and include the cost calculation. Also, this takes a while, as you can imagine, but it's also maybe feasible. So yes, and meanwhile, maybe Gerhard, I take the opportunity to respond to too late. Sorry, maybe I need to. ILCD was too late. Sorry, I need to wait a bit for the chat to because I have some delay. I was too fast. Sorry for that. But I can tell about the regionalization, Gerhard. It works now okay, I think, but it's quite an effort to do the first calculation because with shape files that we have now, always intersections need to be calculated, and that really takes hours. So no, I'm not sugarcoating this. Also, it really takes hours, like 3 hours. It needs to be done only once, but it's in effect not really practical. And I can tell that we now work on a different approach, which has the same results, so also allows very detailed regionalized modeling, but is much faster and also does not use shapefiles, which are also a bit out of the normal, maybe comfort zone of an LCA modeler. So therefore, this is also not it's a bit heavy. You need to use other tools to edit them and so on. Therefore, we have now found a very nice solution that will come up maybe end of this year or so in the next version. But let's see. So now we see, you've maybe seen this already, but for those who haven't, this is the result analysis of the graphic paper production that we have calculated. This is an overview. The screen here is a bit smaller, or the resolution is not as high as usual. So normally it fits on one screen, but maybe it's fine. So here you see just the 5 main contributors in different impact categories. And here you see just all the inventories. And sometimes nice, but sometimes also, typically this is more for for entering the analysis. What is really quite interesting is, I think, inventory results and the impact analysis. Here, inventory, you of course have calculated the inputs and the outputs. So all the resources on the input side, obviously, and you can also here, it's by default filtered that very small contributions are not shown, so below 1%, but you can change that. And you see here that which process contributes to this resource demand. And you see also here that is, I checked the data quality calculation, and this means reliability, completeness, time, geography, and further technical correlation. You see here the aggregated data quality results, which are quite interesting and convenient, I think, to really understand there how the result looks like. And you see that it's quite different from one to the other substance. So here this looks very good. 1 is perfect, remember, and 5 is worst. And here for some it's really quite bad. So this is just the original EcoInvent setting, you could say. And this, I'm not sure if someone understands this, but for us it's also very convenient and not available elsewhere. This shows the total requirements of each of the 14,000 processes that is contributing to the system. So I mentioned that I've got, it was electricity, medium electricity, also medium voltage electricity is 1,400 times used. And that doesn't show the overall amount. Here we see the overall amount aggregated over all the different instances of a process in the product system with which the process contributes. So obviously, because we calculated graphic paper production, this contributes with 1, but then we have others that also, of course, contribute. And there you see then really how important each process is for each for your system result. And it gets, maybe you agree with me, even more interesting when you look here at the impact analysis, because there you have different here the different impact categories according to the method that you selected, of course. And there you see, if you click here subgroup by process, you see here then the contributions from the different processes that again here contribute more than 1%, which you can change in different flows. And also here the quality assessment is visible. And I think this is really, when you want to see what is mainly driving my result, this is very powerful, and this is not possible in another software, LCA software that I know. So for us, it's always very interesting to find to use this to detect really hotspots. If I don't check this here, then I get this result. So then I see this it's not this intermediate level of the process is removed, and you just see then overall these are fossil resource scarcity is crude oil, gas, and coal. And if I say, we can test if this works. If I say 0, it takes a while, I think, but it should also be fine. And then you see then after some time you see then more impacts, but maybe also not. I didn't test this. Or maybe these are all the contributions that you have. Yeah. So you see that for some you have quite. Yeah. So yes. So here you have that was everything. So therefore we didn't see more. Here we have more, and you see also that sometimes you have also here you have also positive, or here negative impacts, meaning positive contributions that are overall aggregated to this result. Yeah, so this is quite, I think, gives you quite a lot of insights, and we find this very useful. I don't want to explain all this, and maybe it shouldn't be a normal OpenSCA introduction also, but here this shows you the contribution tree. That is maybe also worth explaining. That is basically, so the system that we analyze in EcoInvent is always heavily looped. So you have typically a process somehow contributes to itself again. And we here in this contribution tree try to cut these loops so that you don't have a loop anymore, but the process is, each time it is visited, so to say, in loop, it appears here in a linear branch of a supply chain. And that allows you then to cut down the contributions for different branches. So you see here, it's here the first inventory flows, but it gets more interesting maybe if you look at impacts. Let's take again fossil resources. There you see we have 100%, 11.2% come from market for zinc concentrate, and here 8.9% come from the zinc mine operation, and here 1.9 come from diesel, and here and so on. So you can imagine this is really gets quite detailed. You can also export this, copy this, and also mark everything that you see and export this to Excel for further analysis, and that's quite interesting. And then only one further point I wanted to show is the Sankey diagram. So now you don't see it really here, but this is then the showing the contributions of the processes. You don't see now for which what was calculated, and that is again here fossil resource scarcity, and it's by default here set threshold so that you don't see 15,000 processes which are all somehow not really contributing but focusing on the main contributors, and this is sometimes also interesting. Sometimes it's a bit like, if it's like here, so everybody's not contributing much, you don't see much, but here you see, of course, this is our final process that contributes everything, but here then you see that you have a hotspot here and not in these intermediate processes. What is different to also other tools is that you can rearrange this so you can, it's not fixed, so you can move this here and there, and so if needed. Yes, Gabriele, I think I answered Gerard's question. So if not, then post a new question. Sorry, but I think at least I tried to address it somehow. Yes, so that's what we wanted to show here. I think we have also then projects that are basically you can compare here different product systems, and also I can just open this and I won't do it now here, but there you can. It's a bit funny because you can create an HTML page with the results from it. You can describe it here and then select a method, and then here include product systems like this, and then you can define the allocation that is applied in the product system, and override an allocation that is used in the product system otherwise. And maybe also make you can also have the same product system several times and say, one time I use economic allocation, one time I use physical allocation, for example, and then compare results, and you get then this as an HTML report. And then also we don't have parameters here, but when you make your own study, of course you typically will have parameters, and then you can also, very similar to before, you can then say this parameter in this for this process has this value and this value, and then you can make very nice sensitivity analysis. But that's not too fitting now for eConvent, but for for when you have parameters, as said. The data quality means reliability of the source, completeness, geographic, technical, and further temporal and further technical correlation. Yeah, sorry. That's it should be explained in the handbook, but I understand it's not really accessible, also, you could say. I thought maybe it's interesting, instead of doing this, to show you how you make your own project or product system with OpenSCA and eConvent, and therefore, if you agree, then I show this. So process created like this, and I create a new flow for this that is mass-based, and then of course it looks now more empty than the quite completely documented eConvent processes, but otherwise it's also a process, of course, with the same sections. And then you see by default, because I selected mass, it's 1 kilo. I can change this if needed. And I can then say, let's enter here electricity, for example, if I can write it correctly. It always jumps to the first option. And I can select, for example, then this, medium voltage electricity. I can then say this should be provided by, let's say, no, sorry, not India, but Europe without Switzerland. And then I also say I have a waste flow. Like this, and let's say it's not 1 kilo, but it's like this, and this could be my very simple process. And since I selected here from eConvent this is already linked, yeah, with Econvent, and I can then again here say I create a product system, and I again say auto link processes, and then again after some time, but I have here this, and now it's the very different process from the graphic paper production. So now I have only two, of course, inputs, but these are, you see, these are linked to a lot of other processes, and therefore here, if I go to the statistics, also here, I typically, again, as I said, have again the same amount roughly, namely almost the complete database included. Yeah, because then, yeah, it really links then these processes link then to other processes, and that's, yeah, that's basically the idea also of Econvent, to have one coherent linked system, I think. Okay. That's the end of the live presentation. I don't know if you've because of we have quite some lag, I think, so therefore I can just proceed with, I think we have something like 2 slides left, and then we can answer some questions that you may have, if you agree. Is that good? If no one protests, and you can't because I I then go here, and therefore, yeah, it has 2 answers. This waste flow approach is implemented in our versions since the previous version of Econvent 3.6. And in older versions we didn't do this yet, and therefore the conversion, they don't fit so nicely to the existing Econvent database, and the ID numbers are also different. Therefore you can use a Python script that we have and provide for free to convert the older versions to this newer waste modeling, and then use them with or replace and overwrite Econvent 3.6 or younger, older with 3.7. And if it's 3.6, then the ID numbers are the same. If you import in a JSON format the database into an Econvent 3.6 database, then it is overwritten, and therefore you can then replace older Econvent processes with newer Econvent processes. I can tell though that for us it's often that we work in one project with one version of the database, and therefore this migration is not too pressing, but of course sometimes there's really the need, and then this works how I have tried to explain. Last slide, we have a bit, because for us really, I said we provide many databases, but Econvent is quite popular and also important, and I think also good, if you want. Nothing is perfect, but good, really. And we provide, therefore, in Nexus also a family of other databases that extend Econvent, namely Eugeos is a database to especially refining or extending Econvent so that you can use it for EPD creation, environmental product declarations, following in 15804. Provided by our UK partner Eugeos, Chris Foster and colleagues. SOCA is a social add-on provided by us, that where Econvent is enriched by social information for the different processes, so social indicators that we take from our Psilka database and convert this to the process structure of Econvent. Plex is plastic litter extension of Econvent that we also have announced already, I think, and will very soon, like next week or so, really release. This is an extension that just adds plastic litter that is released by the processes to the complete Econvent database, and so you can also calculate the plastic litter emissions from a life cycle. And of course Econvent itself. it's also part of the family. And everything, all this is available on Nexus if you are interested. So yes, so now I hope we have some questions that I haven't answered in between. I see it's good to see that some have asked something. So for us also, I mean, maybe for you also, it's a bit new, this live streaming, but I think it has quite some potential. So therefore, we thought it's good to try this. So is there anything that I should talk about now? Someone said that the Sankey diagram hangs up. It can be, so you need something like with Econet 3.7 it has the database has become even bigger, and because the concept of the database is to always include. No, I'm not anymore in the and it gets dark here, you see. It's it contains always everything, and therefore it's quite large. You need to have something like 6 GB of RAM that you can allocate in OpenSA, and then this should be fine. Yes, Jorge, I don't know how to pronounce. Good question. What is the difference of selecting the provider at the process level or at the product system level? Let's see if I can show this. So when you do this in the process, this is the default provider. So meaning when you have OpenSA create the product system, then this information is used to automatically select the next providing process. You can also have, but in Econvent that's not really recommended. You can also have an interactive mode. When I click here, you see here this check multi-provider links, and then you get a list and say, okay, here we have different options, which one should be taken, and then you can proceed to the next level. But this is really when you need to do this for 15,000 processes, where you have often quite many different options not recommended. But this is the default provider. In the product system, you can change this. So you can edit this connection and then remove it and link this to remove it and add a new provider process manually. And that's the difference. So it's more convenient if you want to make this on the process level initially, but especially for us, it's really typically that we don't change this for the Econvent database, so we leave this with the providers as it is. But when you make a foreground system, then it is good to especially in processes that you need to or would like to use in different ways and not always wire to one specific provider, it is good to leave this open and then decide this in the process, in the product system that you create yourself. So, because what we see here is the process as it is stored in the database, and it is always like this. And you could use this, of course, in different product systems, but then always this provider would be used for the linking. And for example, if you want to play around in your foreground system and have different end-of-life scenarios or so, then it can be quite convenient to change this provider and to modify this in the product system. And then you shouldn't make 5 copies of this process. You can, of course, solve this to some extent with parameters that we can explain a bit more. It's a bit more advanced to do this, but this is possible. But it's also very nicely possible to just make a new product system that has a different provider linked in the product system. And that's then, it's very flexible and not stored in the database otherwise. So therefore you can make different data product systems with these different connections. Good question. Anything else? Did I forget anything? I don't. This. Thank you for the reply, Jorge. Disordered. Yeah, it's. I think it should be alphabetically ordered, but of course, maybe sometimes it's not. Especially what we saw for electricity or so, when you have really 200 providers, that can be, like I showed in the, or like we had in the example, this can be a bit hard to find the appropriate one, of course. But yeah, I can tell sometimes, of course, this. If we have this ask forum also, and there sometimes the question is, I can't find a provider, and this is then because you don't have a product produced by some other process that exists. Yeah, so that when you just create here, like I did in my process here, when I just create, I created here a flow, and I can also create just another flow. And if it's a product, here again, so you see it's now here. And if we go to this process, I can say, okay, I want to include this here. And then, of course, here, I don't find anything because nothing produces this product yet. And therefore, this is, yeah, you first then need to create a process that is here, like here, produces this product, and then you would be able to find a provider. So that's quite a common, not complication, but a common question when you start with doing life cycle assessment models, that you don't find a provider, and therefore you are stuck somehow. But this is the reason. Now, further questions? Also, maybe I can say that because we are a bit trying this, so if you have feedback for us, how we can, if you think this is good or we should change something or improve something, that's really appreciated. Yeah, because I think I thought especially now, because we don't go to conferences anymore really currently, and practically probably nobody of you either. This is also a way to quite easily reach out and to explain something. And we have ideas to expand this also a bit, to do this a bit more regularly somehow. You can expect the next of these streams in 2 weeks. Topic will be announced. And of course for us it's a bit that we, of course, would like to hear feedback from you, what you think could be improved, what you miss, what you like, and so on. Susanne Hoffman, may I ask a question regarding data quality? Yes, you may. Why is the standard deviation in the uncertainty column not the same? Yes, this is because so everybody has read the question, I think, or you are invited to read the question. So question is why the standard deviation that we see. So I didn't show this, but we have here an uncertainty column that shows also, that is also part of the information provided by Econvent for every flow that is not the product of a process. You see typically a log normal distribution, and then a geometric mean and geometric standard deviation. And then you see also this, and this is different from always in what we provide. This is different from the information there, and this is because Econvent has a formula to calculate the standard deviation, or it's always here in the Econvent version. It's always log normally distributed to calculate from these settings the standard deviation. Then you know that in addition you have the base uncertainty. So depending on the product and the process, you have a slightly changing uncertainty in addition, and that is, according to Econvent, added up to an uncertainty for that can then be applied for expressing here the uncertainty for each flow. But this is of course a bit debatable whether this is at all possible. So therefore we thought we shouldn't establish an automatic link, also because that's the software, and the software needs to be also flexible for other databases. So if you would like to do this, then you need to do this yourself. So it's your own responsibility to enter here in uncertainty the correct, if you want uncertainty, link to this flow. And you can of course adjust this here in the data quality settings, get then from this table the correct, or according to Econvent, calculated uncertainty, and then enter this in addition, or replace the existing uncertainty there. And I didn't show, but here this is what we have used here, and you see it's also zeroed, so it's a bit funny, but that's because I had really the pleasure of, in 2010, I think, having a project with Bo Weidemann and Stefanie Müller. Bo Weidemann was then technical director of Econvent, to propose a different way to do this uncertainty factor system. But now we use, for the Econvent database that we distribute, we use this. You can also create your own here, and there you see this is the different, you can really change this also, so you can add here scores, or you can remove indicators or add indicators, and then you enter these basically uncertainty factors that are used according to Econvent to calculate the overall standard deviation based on these settings. Yeah, so this is that is possible, but it's a bit, of course, I shouldn't say, it's a bit debatable and quite a strong move if you say, I know that because it's here 3, this contributes this much to this standard deviation, and therefore we don't do this by default, or we don't do this, but leave this to the responsibility of the modeler. Hopefully that's answered. So next, so for me, I can say feedback, you are a bit quiet, but otherwise I think it's quite okay. So at least I feel quite comfortable doing this, which is also good. But any next things I should address? Yes, and in the chat you see also that we have some, of course we have found our YouTube channel, but we have some tutorials, and we have also a complete handbook on how to use OpenSCA. That maybe is also interesting when you go more into detail. And then I don't have slides for this, but we offer also training and support if needed, of course. And it's quite, for us, it's quite really maybe concluding nice to see that OpenSCA is now expanding so much, and it's also a bit responsibility for us, of course, to provide a good tool that is really useful. And also one part of this is to also make good databases available when quite fast when they are available, and not wait too long. Because it's also for you useful, I think. Yes. If there are no further points, then I can activate this slide again and wait until it appears also for you, and say thank you also on behalf of Salva, who you haven't seen here, who sits in the dark there. And as said, we will try to do this more frequently, and maybe like a regular interval to make it more convenient for you, also like every 2 weeks or so. I think for us Friday is quite a good time typically, but of course it's in the end it's also a bit flexible, and topics really will be around here about OpenSCA and how to use it. So thank you very much, everybody. Then I need to see how I can close this.